Good morning and welcome to the Open System Firmware track of the OCP Summit. My name is Ron Minnick. I'm a software engineer at Google, and I'll be talking about what Open System Firmware is. We shorthand here being OSF, and also the transition schedule we have, which runs from now through March 2021. So what is Open System Firmware? There's been a bit of confusion on what OSF is. OSF does not require that you open source all the firmware products your company creates. Open System Firmware is an open development project, and the goal of it is to allow OCP owners to own their firmware. In other words, we want to move the point of control of firmware to the system owner, not third-party owners of software. Owners have to be able to change their firmware and share it, and that includes any binary components that came with the firmware with other owners. That, again, is not requiring that you as an ODM or a chipset vendor open source every last bit of the firmware you provide. It merely requires that owners be able to build new firmware images, install them, use them, and distribute them. So is OSF open source? It is in whole or in part. In whole, it's open source on IBM Power, RISC-V, some earlier x86 systems or some x86 systems not made by Intel or AMD, and parts of the ARM ecosystem. It's open source on part, largely on Intel and AMD x86 systems. Now, I want to note in passing that until 2005 for Intel and 2014 for AMD, there were full open source firmware systems for those processors. One of them was called Linux BIOS, which is now known as Coreboot. And I personally built some top 10 supercomputers using Linux BIOS. There are also some very large companies that use Linux BIOS for their systems too. But we do not require vendors to deliver firmware in open source form. As long as you give us something that we can change, and a good example of that is the EFI firmware volume, we can take that firmware image and we can insert open source components into it. Many of us are using Linux kernels inserted into UEFI, for example, and Microsoft is using the EDK2. How can OSF be delivered to system owners? There are a couple ways for this to happen, and I'm quoting here directly from the web page, so no need to write these notes down. You've got many ways to see this text again. The most convenient, of course, is you give people source and they compile and install it, and that's what happens on IBM's Power systems. But another way to do it is you deliver the firmware in a binary, but it's componentized, which means that it kind of looks like a little file system in Flash. And you can do operations equivalent to removing, modifying, or replacing files or components in the image. So we view binary firmware images as far less desirable than open source, but the Open System Firmware, or OSF specification, allows binary firmware images to be delivered to owners, as long as they can be changed. Transfer of ownership is a very, very important part of OSF. Owners of OSF systems can transfer ownership, and new owners have the same level of control. The first transfer of ownership actually comes from the manufacturer to the first owner. So, for example, if Facebook were to buy a system from Lenovo or HPE, Facebook would become the new owner, and Facebook would have the ability to replace the firmware with their own. If there's signing needed, the owners always own the keys, not the manufacturer as today. And the other big change in the model here, the owner owns the firmware, not just the hardware, and the owner can transfer that ownership to a new owner. Are there systems that follow the OSF model? Yes, in fact, there have been systems that follow this model for 10 or 20 years. One of the most well-known is Chromebooks. With a Chromebook, an owner can rebuild the firmware from binary and source components, create new keys, install new keys into the hardware any number of times, sign the firmware with their own key, and make those firmware images redistributable and downloadable. So there's no problem with the Chromebook in doing all the things we've talked about for OSF. There are some IoT boards also, the UpSquared board, the Minnow board, for example. If those systems have Coreboot installed instead of the standard UEFI firmware, owners can download, change, install the firmware, and redistribute the changed firmware they create. PC Engines, a company that's been around 15 to 20 years in Switzerland, has always allowed owners to download, change, and burn new firmware images and redistribute images they build. By the end of 2020, we are told there will be several tier 1 server companies also conforming to this model. Here's some more links to key documents. First document is the transition schedule. The second document is the compliance checklist. These are open. We welcome comments on these, so please take a look if you have time and let us know what you see and what we might need to change, that sort of thing. Why are we doing this? So occasionally when you put the word open in a thing, people decide you've got some kind of agenda, and we do have an agenda. Our agenda is security. Let me ask a simple question. When's the last UEFI exploit? In general, the last UEFI exploit was about 2 weeks ago, and that applies here. So 30 March 2020, the ISIO2.sys exploit, you can Google that, was found. And that exploit, people are working to see if they can use the exploit to take non-privileged process on Linux and make it privileged. So there are active experts working in this field to see what vulnerabilities that UEFI exploit creates for users. So firmware is a great place to embed attacks. UEFI is and has been a target for some time now. If the exploit is crafted carefully enough, your only option, if you have one on your system, is to shred your motherboard. So what we've learned here is a lesson everyone has learned, which is security through obscurity flat out does not work. And the owners of these systems need as much visibility into firmware as possible. We need friendly adversaries attacking it because we've already got a lot of unfriendly adversaries attacking it. And the deal here is, it's not so much that we want many eyes. We want lots of high quality eyes on the software that goes into firmware. And that's one reason we want to embed Linux, many of us, in firmware, because we view Linux as very, very high quality software that has a good security story at this point. We get a huge improvement in boot time performance with this approach, and we get lots of good flexibility. That's a nice side effect. The starting point is security. Is OSF optional? Today, OSF is optional. Since we started the OSF project a few years ago, OSF has been optional. But starting in March 2021, if you want an OCP badge on your server that you claim is OCP compliant, you must support OSF. There will be no option. So let's take a look at what that might look like in 2021. We have got a company, Big.co, and they need 100,000 servers. So they go to Stir.com because they know Stir.com is OSF compliant. Those servers come in the door, and the first thing Big.co does is take the SPI parts from containing the firmware and shred them. They then download a clean firmware image from Stir.com. They modify it to contain different images or pieces. And you know, it might even be that the image they download is already an OSF image because Big.co and Stir.com collaborated, maybe with other companies too, because that's allowed now in this model to produce that initial image. Big.co burns the new parts and deploys them into their data centers. Now here's where it gets interesting. The next step Big.co takes is to post that modified firmware on their website so others can test, attack, and use it. This is the friendly adversaries model. Or to a GitHub repo. They might advertise the availability of that firmware. They might accept bug reports and fixes, and they might even share those bug reports with Stir.com. In fact, they almost certainly will. And look at the advantage for Stir.com. Their security group just got grown by a factor of 10 to 100 because now it's not just Stir.com employees looking at security, it's everybody who owns that server. Finally, Big.co might deliver the modified firmware to a third-party continuous test facility of the kind that ITRenew has been setting up. All right, so how do we get there? There are two key documents. I mentioned them earlier. I'll mention them again. I can't mention them enough. There's the OSF checklist, and that basically says, what does an OSF system have to be? And the transition schedule, and that says, when does an OSF system have to be? I'm going to go over these dates real quick because they are important. March 2020, we were going to announce the schedule, then the coronavirus happened, and that was that. So we were announcing the schedule 2 months late. Sorry about that. September 2020, there are going to be some vendors planning to announce that they have a limited availability of compliance systems for evaluation. So those of you who want to get a look at this stuff before the actual deadline comes into place, you should be able to get them in September 2020. We were going to announce this at the OCP Summit in Prague, and the coronavirus intervened, but we're going to try and make this work out. March 2021, the compliance rules come into effect, and at that point, it isn't an option. I should also mention we have a bi-weekly conference call. If you could join, that would be very nice. We really welcome everyone. We've had great participation from the manufacturers, chipset vendors, and owners, and it's really helped us to shape that requirements document and that schedule, by the way. We worked very closely with a number of chipset vendors and manufacturers and owners, and that schedule really was very, very carefully vetted. OSF is a big change for OCP. So until now, firmware has been created, owned, and installed by one of several third-party software companies, and you really weren't allowed to change it, and you really weren't allowed to give it to other people, and you really weren't allowed to study it very much. So that's the way it's been, and that's not working. At least from the security angle, at least, it's not working. So we're moving to a model where the firmware is owned by the system owner, who can recreate and share it. The ownership of the firmware can change as the system changes ownership. And finally, firmware redistribution is under control of the owner. If Facebook or Google or someone builds an OSF image for an OCP server, the rules of the road are they can put that on GitHub and offer it up to anyone else who has that system or a different system. Because the big picture here is you can't really get security from obscurity. You can only get security by having a lot of people taking a look and attack things to see what might be broken. Anyway, the rest of the day, we've got some really terrific talks. We have a panel about a few hours from now where we're going to talk about the schedule. And I'm really glad that you are here. And I hope if you have questions, you will dial into our bi-weekly telecon, or you'll send me an email or get in touch with OCP, or whatever way you're most comfortable with making your thoughts known. Thanks again.